Okay, so I've been, I don't even know how to say this, extremely busy at not being busy. About 2 weeks ago, yeah, it got to the point where I don't even remember what part it was. My inventory was starting to get kind of low. So I went to reorder, and then I started looking at other stuff, and it was like, oh god, yeah, there's just a lot of stuff. Because when I buy parts, I buy in usually very large volumes, so I don't have to order very often. Especially parts that I'm going to be using almost on a daily basis, like electrolytic capacitors. I don't want to have to be reordering every week or every month. I like to do that maybe once or twice a year. In semiconductors, I'll buy a lifetime supply. If I need one transistor, I'll buy 100 or 200 or 500, depending on the price of them. And then I never have to worry about ordering them again. But I was getting low on a lot of my what I call the normal consumable parts. And yeah, between that, getting two new computers, now filming with a new digital video camera. Got a couple digital video cameras. I just before starting this video got in the macro lens for the. Well, actually, it's a yeah, I guess you'd call that a macro lens. It's like what is it, 0.43 times lens? Because with this camera zoomed out the whole way, yeah, things were just a little bit too big in the screen. So with this new lens on here, it kind of shrinks things down and keeps it much better. But it still allows me to zoom in like I want to. New Shure wireless microphone system, so that's what I'm talking on. I can actually show you the transmitter. So there's the little transmitter. Microphone, let me take it off my ear for a second and I'll show you. So there's the microphone. Get this put back on now. So that's what I'm, and then the receiver is attached to my camera mount, and then the jack plugs into the camera. But, so, in any case, this is probably the first radio I've worked on in close to 2 weeks. About the only thing I've touched radio-wise in the last 2 weeks was occasionally I might reach over and turn one on and listen to something. But yeah, I've just been either ordering parts, receiving the parts in, putting the parts away, setting up new computers, yeah, digital cameras, playing with video editing software. I'm technologied out, man. So, finally think I got pretty much everything squared away, and we're finally back to, or I'm finally back to time to work on radios again. So first one on the bench is this one, Cobra 148 GTL Custom. Yeah, it's got a custom faceplate decal, says custom on there. So the owner bought this on eBay with all the modifications done to it. So all I've done is basically take the covers off, hook it up to a power supply, hook a microphone up, hook it up to the communications test set, and basically just go, oh my god. It's pretty much the extent of what I've done to it so far. And maybe we'll dig into it a little bit here on camera. So the customer's complaint was receive is horrible. And I would have to agree. Receive is horrible. He said on sideband, yeah, it's not. Now he's a collector. He has a lot of radios. He knows what a Cobra 148 should sound like. And it does not sound like that. Now, I transmitted with it, and that was actually the first eye-opener for me. I was like, oh my god, what in the hell has happened to this poor radio? So, let me actually show you that. So, I've got it hooked up to the communications test set. So, if we look at it, and you'll have to bear with me because I'm got to remember all new equipment, learning to use all this stuff, to include my mount, which is also new. So I've got the span set to 10 kilohertz right now. So that's one channel. So if I key, make sure I got the mic gain turned down the whole way. So this is just a carrier. Nothing else. No modulation whatsoever. I'll key the mic. Oh my god, what is that? That should not look like that. I'm almost speechless. I don't even know what to say. I mean, what we should see, grab a pointer here, This is what we want. This is our carrier. But it should drop. It should basically look like this pointer. You should have a peak right there, very narrow. It should drop down, and you're always going to have some noise down here. But it should be way down here, and then you should come up to a sharp peak and come back down and continue on. This thing, as we can see, is bleeding. Yeah, it's definitely bleeding into at least one upper and lower adjacent channel. So actually, let's just set the span to 0.03. No, not point. The hell did I just type in there? No, not minus. Nitwit. Accidentally hit the minus sign. Wow, there's 3 channels. And it's bleeding out farther. So let's set it to 0.05 or 50 kilohertz. Yeah, and it's still bleeding. I mean, this thing's probably bleeding like 7 to 9 channels, something like that. And then if you look at it on the oscilloscope here, modulation is just, wow, that's, again. So let me turn the mic gain up. So the oscilloscope is attached to an IF output on the back of the communications test set. So there's our carrier. And let me just whistle into the mic. Boxcars. What else can you say? Yeah, that looks pretty horrible. Now, receive. Yeah, also not too great. So let's turn the volume up here. So there's, what do I have? Let me get reset up back up here. Let's see, generator level. That's minus 110 dBm. So it's receiving okay. Let's just turn the level down. Yeah, it's even, I can still hear a signal at minus 120. It's not amazing, but the biggest problem is all that background noise. Now here's the kicker. Disconnect the signal generator or the communications test set. So there's nothing attached to the antenna jack right now. And turn the volume back up. What is all that noise? Yeah, I mean, there's going to be some noise, a little bit of noise, but yeah, that's like, oh my God. I'm at a loss for words there too. So, this thing needs help. Let's just get the camera straight overhead here. So, let me just turn off the communications test set and scope over there. We'll get everything unhooked. Now I can see there's been a lot of work done in this radio, obviously. It has a Channel King board, has been installed in it. And that installation, the work looks very neat. Wires, yeah, I mean, wow, you couldn't pull a wire out of this thing if you tried. You'd rip it in half because all the wire ties. So it's very neat. Electrolytic capacitors look like they've all been replaced. Looks like good brand name caps. I'm not sure about, well, actually, they have spoken too soon, possibly. Yeah. I was wondering if those are some of them Chong or Chang or... Yeah, those are... Those two, that one and that one, the two large filter caps look to be kind of no-namers, but looks like the rest are a mix of Rubicon, some Matsushitas, there's some... yeah, it looks like mainly Rubicon, and I think it might be a Nichicon back in there, but it looks like the rest of them are name brand. So yeah, those two caps, I'll change those out. So let's just get, because yeah, that wide like pyramid for RF power, there's something seriously wrong in the RF section of this radio. So let's take a look and see what the heck could possibly, let me get just everything unplugged before I take the last screw out there. We can just pull this entire board out. I'll do them once I get this off. Just really quick, turn it on, back off, make sure all the filter caps are drained. Now the first thing I notice when I do a Channel King board, it's a good idea. The displays on these, you have to remember, they're 3-channel. They're PWM, or pulse width modulated, driven. So it's not like the original channel display that was in this that just had a constant voltage going to it. These are, just as the name implies, pulse width modulated, or PWM. So it's pulsed, or it's just, and that's how you control the brightness of the display. With basically a pulsing voltage. The more times it's on, the brighter the display. The more times that pulse width modulated signal is off, the dimmer it gets. But it's digital, and that's the key, and you'll get some digital noise, which I do hear a little bit of digital noise, which isn't uncommon with these boards. You're going to get, it's just a fact of life, you're going to have a little bit of that, but you can prevent a good bit of it by shielding this cable right here, because this is the one that goes from the driver right here out through this socket to the cable up to the display. So this cable acts as an antenna, and it's broadcasting that, basically, that digital noise into the radio. So we don't want that. So yeah, just, it's real easy. Just take some shielding tape, RF shielding tape, wrap it around there. That'll cut a lot of that out. Let's pop the little echo board loose here too. Smaller screwdriver. And we'll just go through this thing and see if we see anything. Now, like I say, the work looks very neat. Yeah, maybe easier said than done. Come on, there we go. Like I say, wires are very well tied. So what do we see? Well, there are some green parts, and I don't mean green as in corrosion. Zoomed in here a little bit. And you're going to have to work with me here over a period of time as I get used to my new camera setup and the camera and everything else. Until I get comfortable about how I'm using it and whatnot. But one of the first things I see, there are some parts. Well, I mean, caps have been changed, but other parts. So, if we look down here, I can see there's a green resistor right there by the SWR bridge. And speaking of, yeah, the glues, yeah, it's the corrosive glue in this radio has been, I guess you could say, partially removed. It's still in here. It looks like somebody really quickly took out most of it, but they left a lot of it in. Now that resistor, that might be why that's been changed. If the glue corroded the lead off, or it was just too bad to be cleaned, they just put a new one in. But yeah, you can see that wire right there is still all corroded. This SWR bridge was not removed and cleaned, so the glue's still up inside of that ferrite core. Let's see, another green resistor right there. There's another green resistor right there. So, when you're trying to find out what might have been done to something like this, that's one of the first things you can do. Just look for obvious parts, things that just don't look right. What looks like it's been replaced. So we can see those resistors, like that one there, definitely were replaced, and the one in the SWR bridge. They're a different color than any of the other resistors in this radio. There's nothing wrong with them being green. Probably higher quality than what's in this radio to start with. But why was it changed? Now, if it's like the one back at the SWR bridge, yeah, that was probably changed because it was just corroded. These, I wouldn't think so. That one, yeah, there's really usually not any glue here, and there's usually not any glue right here. There'll be glue over here, but not here and not here. There'll be glue here. Actually, that resistor, I can get it. You see that one? Look how green. Now that green is corrosion. So, some of the glue was taken out, but yeah, the corroded part's still in there. But, looks like that resistor just looks a little bit, actually that one and that one look a little bit too clean almost. I'll have to check the values of those. So, they're the same body color as what would be in here, but yeah, they just look awfully clean. Even the lead is really, really shiny. Compared to other ones that are laying flat on the board, they look kind of new. So no guarantees that those have been replaced, but I need to check the values of all those because we definitely have a problem in this area somewhere with that huge RF emissions we're getting out of this thing. Zoom out a little bit. And the underside, nice and neat. There's not a lot of bodge parts on here, just some wires over here, because it does have talkback. Looks like there's the resistor in there. And it looks like 2 of these switches have been repurposed. So the bright dim and the high-low switch have been repurposed for something, so check them out. One of them obviously is the talkback. Yeah, there's a solder bridge there, so that's definitely not helping. That's part of probably why it's splattering. But yeah, I need to check those parts. And the modulation was, horrible. It looks like the limiter transistors are in there. Yeah, there's definitely been work in here too, though. That capacitor and those 2 electrolytic capacitors right there, right off the bat, I can see they're not supposed to be electrolytic capacitors. Those are supposed to be film type, like this green poly dip right here. Yeah, somebody's done a splatterbox audio modification to this. So, yeah, it just... And receive, yes, it's got Schottky diodes, which... Do they hurt anything? No. Do they help? Not really. Honestly, I used to do them years ago, and it's just a waste of money, honestly. It's something that a shop can sell you, but yeah, there's blue diode there, so yeah, the Schottky diodes have been installed. I'll leave those, they aren't hurting anything, and yes, it looks like it's got a 2SC2999, because the transistor's a lot smaller down in there. Well, that ain't right. Even for doing that modification, this definitely ain't right. Let's get zoomed in here a little bit more. That, where's my pointer at? The camera here. That transistor has been changed to a 2SC2999 as well. You're not supposed to do that. Yeah, both of those will come out. That one and that one over there. That's the normal modification right there. You install the 2SC2999 first RF amp. That one, no, that's not supposed to be there. Even the, which I guess you'd call the published modification, that definitely shouldn't be in there. The problem with doing stuff like that, and it's why I stopped doing these receiver modifications, they actually kind of like doing a lot of your transmit modifications. They don't really improve things. If anything, they make things worse. You have to remember, this is the first, it's called the first RF amp for a reason. It's the first one in line with the antenna jack, so it's amplifying your incoming signal. Well, the problem is, if you were to do a modification, you might want to do it in a later stage, like at least after the mixer. You don't want to do it here because, and people put these transistors in because they have higher gain. They figure, well, if it's got more gain, it's going to amplify more. I'll be able to hear better. Well, yes and no. I say no because the signal also includes all of the noise. Anything that's coming in, the trash, everything is being amplified. So the signal you want is being amplified, but everything you don't want is also being amplified. Well, that's not doing you any good. So, yeah, just waste of money. And, like I say, reduces receiver performance. I can't see those two doing that much damage to the receiver circuit in this, or making it as horrible as it is. I'm really just going to have to go through this thing with a fine-tooth comb. Yeah, like I say, the work is neat. I can't gripe about how the work's done. Like I say, it's got the fancy decal. Now, the meter does stick. Customer even actually sent a replacement meter along. So I guess this just had the white background shoved into the original meter probably. But yeah, that's apparently hanging up. So he wants the new meter installed and take the white background out and stick it in the new meter. There's no holes drilled in the back of it, so yeah, it doesn't look like it ever had any switch mods at any time. No signs of any tracks being cut here from the looks of it, so it doesn't... I just got to get a little closer to my face here to actually really look at it. No, doesn't look like it ever had probably any switch mods done to it for channels. So, the Channel King board, here, that's in it now, and the PLL adapter board's probably its first shot at extra channels, and that's a good board, like I say. And the installation looks fine on that. Like I say, other than I just put some shielding tape on there. That's just a good idea. Yes, it's got a 10-turn clarifier. And control's been changed. That's for the echo right there. Does have LEDs. I don't know if you noticed when it was turned on, there's blue light coming out around all the switches. LEDs, I guess the faceplate was taken off and holes drilled in the metal structure behind there, and there's LEDs in there. The only thing I don't like about that from the looks of it is you can see there's black, actually that black glue that's right there. Now it looks fine here and it looks fine on this one. It's holding the LED in. The problem is that black glue here is also all over the wires and all over the terminals for the switch, so God forbid anybody ever has to work on that one of those switches right there. Yeah, because this glue ain't easy to get off. If you actually, kind of interesting, there's black glue here, but there's hot glue here. Just use hot glue. That's the best thing to use. It's got really good holding power. The big key with hot glue is it's so easy to get off. Isopropyl alcohol. That's all you need. You put a couple of drops of isopropyl alcohol on there, wait a couple seconds, take something like this, boink, it'll pop right off. It just, I don't know, I'm not a chemist, but whatever isopropyl alcohol does, it just completely eliminates the bond of hot glue. So, yeah, that's why I prefer using that. I hate this black goopy stuff, man. It's just, it's so hard to get off without damaging stuff. So, yeah, there's the verdict is it needs some help. I need to check a lot of parts. Now, like I say, if you're doing something like this yourself, you're trying to figure out what's wrong with it, it's been modified, look, like I say, for obvious parts. Green resistors. There were no green resistors in this radio when it was new, so they're obviously, check them. If you don't, look at the schematic for starters. What I'll probably do is, because I really need to check this whole radio, because it's got transmit and receive problems, and lots of them. The advantage I have here is I have pretty much a sample radio of almost anything that's ever been made. So I can go pull one of my sample radios that's 100% virgin, unmodified. I can just set it right here on the bench beside this radio, and any questionable parts in here, I can just look at it. I can look at the color bands. Let's say it's red, 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 so it's a 2.2K resistor. Well, instead of having to look that up on the schematic, spend a couple minutes trying to find the part, what is it, back in the radio, okay, yes, that one's right, and then move on to the next one. If I have a virgin radio sitting beside it, I can just really simply go back and forth, back and forth, back and forth, back and forth, and easily compare to see, are the parts in this the same as in the virgin radio? If they are, that's obviously not a problem. Well, there actually may be some problems. Actually, yes, there are. On the bottom side, there are some problems. I don't know how close in can I zoom with this camera. We're going to find out here, aren't we? Ooh, I think I just reached the limit. Come on, refocus. Come back in a little bit. Now, I gotta pull the radio out here, find it. Right there. Where are we at? That solder joint right there is completely broken out. That whatever part is on the other side is completely, it's not attached anymore. Yeah. Let's see here. Yes, and there's a couple more back in the in the RF section. And all of this is the RF section all around here. Right there. If you can see the halo the whole way around that one. That one's busted out. Where was that other one I saw? Trying to look through the viewfinder. Oh, for Pete's sakes, I saw another one. Where was it? Oh, right there. Right. Back into focus. Right there. That one's completely busted out around it. Some of those, very likely, those could be my problems right there. Actually, that one, what do we have there? Yeah, that's a, that's that cap. Yeah, I can feel it. I moved this capacitor. I got my finger on the solder joint below because it's busted out. I can feel it wiggling. You know, you can even see it probably. But that is, I have to check the schematic to be 100% sure, but that's part of a filter network, I think. So, yeah, that could be a big part of my problem, some of these bad solder joints. That might be all it is. I'll check all those parts that have been replaced, but, yeah, bad solder joints, especially if it's in any of the filtering circuitry for the RF circuits there, that could definitely be causing that pyramid-shaped carrier, because, man, that's just, I don't know if I've ever seen one quite that bad. I mean, wow, that's just, it's impressive to say the least. So, let me do some resoldering, checking some parts, removing some parts, all this stuff that was added. I need to put that back to stock factory the way it should be. So it's a good, because we want a good receiving radio that's clean, like a 148 GTL should be. Fairly quiet receiver with really good reception. Transmit should not look like a bunch of rail cars lined up beside each other on the oscilloscope. Should be nice sinusoidal looking modulation package. So yeah, I need to get all this audio junk out of here. So I shall return. I'll let you know what I find. I need to pull some other parts out to get the rest of the glue out. I need to change like that one resistor that's all green. Need to pull the SWR bridge out, clean that up, and a couple other spots in here. Yeah, actually the glue's still all over those three ceramic capacitors right here. They all have little small ferrite bead on them. The glue's still all over those. So, yeah, I got a little bit of work. Keeping my fingers crossed some of those bad solder joints are that horrible RF emissions. So, we shall see. And I shall return. Okay, this poor radio. So, I've got most of the work done to it now. I'm going to have to do an alignment to it when I'm completely done. But I still have the problem of pyramid-shaped transmit carrier. So the first thing I wanted to do was try and remove or reverse a lot of the stuff that had been done to this that could, some of it which might be causing problems. Like I said, check parts that were obviously had been replaced before, make sure they were okay. So all that's been done, and I still actually a few electrolytic capacitors I still need to replace in this. There were more no-name, I don't want to say they're no-name, but they're very low-quality caps. There were several more in here than I thought there was once I started cutting wire ties and taking a closer look. Here's everything I've taken out so far. But yeah, like the big filter cap where we got JWCO, so yeah, some Chinese junker cap, and does this have a name? Yeah, it's another JWCO. Chang or Chong or something. A lot of these other ones you see down in here, they're like Chang or Chong or something like that. Get one of them out of here, actually. Yeah, Cheng X, whatever Cheng X is. Yeah, so yeah, they're out of here. We're not going to be using junky Chinese caps that are going to be lower quality than the original capacitors that were probably in this radio. So those have been changed. Reversed the receive mod. You took out the two 2SC2999s, put in the proper transistors that are supposed to be in there. Removed a lot of that audio modification junk that was in here. So where there were bipolar style electrolytic capacitors stuck in there, those were removed. Green poly dips put back in. The modulation limiter had been disabled. The transistors were not removed. There was a resistor missing, so that circuit's been re-enabled. So modulation percentage is good now. It can be adjusted so it doesn't look like rail cars on the oscilloscope. But we still have this huge, just overly wide carrier that just, yeah, something just not right. The resistors that I wasn't sure about, I checked. Yeah, all the resistor values were fine that were in here, and I've actually replaced a bunch of other ones. I'll get into some of the other stuff once I'm done this. Removing glue, there were a bunch of other parts I changed because they were corroded pretty bad. But once I got that work done, so now I know that the radio's pretty much for the most part, I mean, yes, it has channel king board, has lots of modifications, but a lot of the stuff that we don't want has been removed. Gave me a chance to inspect all the solder connections, which, yeah, this thing actually had a boatload of bad solder joints. So all of the solder connections have been gone over, and I'm 100% sure now that it's not a bad solder joint somewhere. And here's what I'm to. Turn the radio on, still have the wide carrier. Like I say, the audio's a lot better now. Receives probably, honestly, I haven't even checked it. Receive probably still sucks, if I had to guess, because of this problem. Reason I say the receive probably still sucks is because the frequency is just all over the map. So what I have the oscilloscope attached to is the output of the VCO. So the VCO is, actually I have one laying here, is a block in these, okay? They're called VCO blocks. So it's just a circuit board with all the parts on it encased in epoxy with the pins coming out. So that's what they have in these. Matter of fact, that number right there, UHIC007. The output of that should be as your tripled frequency, and it should be a stable frequency. Well, it ain't. It's anything but stable. So if we look at the oscilloscope, that is the output of the VCO. What in God's name? Yeah, it looks like a jiggling spring. So that's sampled right off of TP, what is that, 1, I think? Yeah, that's TP1. Had to look here on the schematic real quick. If I get this in here, where are we at on a schematic? Right, where's my finger? Up here. Okay, I'm going to need to lay this down on a bench. Trying to hold this in my hand in front of the camera right there. That's where I have the oscilloscope attached to. So here's the output from the VCO. Here's your tank coil. And the resistor that sticks up, matter of fact, that resistor sticks up off the board that's used as a test point. So that's where the oscilloscope's attached right there. And that, it comes back into focus, that is what it looks like. Yeah. That would probably explain our super wide-looking carrier. That's because the frequency's doing this. It's all over the map. That ain't right, man. And that's in receive. We're not even transmitting. So that's why I say, yeah, receive probably still sucks because that is so jittery. So I can't say I see any real modifications in the well, relatively speaking, in the PLL synthesizer, VCO circuit. Yes, has a channel king board, but that shouldn't be causing this problem. Otherwise, the circuit looks fine, because basically all you're doing with this channel king board is you remove the PLL, you install a PLL adapter board, which puts a different PLL in, and the reason we're using a different PLL is it gives more channel possibilities. And then the channel king board can program the input pins to that PLL to give it all those extra channels. But the rest of the circuit stays pretty much, for the most part, with in this chassis, with the exception of having to remove one resistor, which removes voltage off of a pin you don't want it on. The rest of the circuit stays unmodified. So, yeah, there is definitely something just ain't right here, folks. So, I kind of got a feeling it might be a bad VCO. So, we're going to stick a VCO in there, and we're going to see what happens. So, let me pause the video here, get this radio flipped over, do a little bit of desoldering, pop in the other VCO block there, and we'll see what it looks like. Because everything else in the synthesizer circuit there looks okay, but when we get to the VCO, yeah, things just seem to go haywire. So that's my first suspect, so let's see if I'm right. Okay, so moment of truth. So I got the VCO block out. I have it changed now. While I had it out, I also replaced, where's my little pointer here? I replaced, zoom in. Since I have a wonderful new camera, I can actually zoom now. Oh, look at that. Man, just couldn't, it's going to make life so much easier. I've replaced this tantalum capacitor, and I also replaced that transistor. Now I had removed, if you remember, I had said there was still a lot of corrosive glue in this thing. Once I got this VCO block out, I found even more, because apparently it had not been removed to clean out the corrosive glue. So if you're going to work on something like this yourself, you're a shopper, you're working on your own radio. People often ask me, what's the easiest way to get the glue out? Honestly, the easiest way to get the glue out is to remove every single part that the glue is touching. Honestly, that's the only way. This is no exception. When I work on a radio like this and I'm taking the glue out, I just pretty much by default remove the VCO block. I'll often remove several other components. It's just like I had to do in this one. We can zoom in on that too. I removed the 455 filter. Okay, so I removed the 455 filter. There's a resistor has been replaced here and here because they were just corroded. There's no way of getting around it. I'm not going to sit here and try to spend several minutes trying to get glue off of a lead when it's just easier to put in a couple cent part brand new. And then you don't have to worry about the corrosion. And several other places in here, just like with the SWR bridge and several other places back here in the final section. Honestly, that's the easiest way to do it, people. Just take the parts out, then you can easily clean the glue off of the leads or parts or toroid transformers, whatever it is you're trying to clean it off of. Another thing is, when you pull those parts out, you are very frequently, if the glue was touching the lead and the circuit board, so let's just take this VCO block as an example. If the glue is touching this lead and it's oozed down the lead, well, that means it's also down into the hole. And just like this one, when I pulled this VCO block out, you could see the green grunge still in the hole in the circuit board. Because you have to remember, the circuit board's got some thickness to it. It's a sheet of fiberglass. You can clean this stuff off the top of the board, but there's still that stuff in the hole, and you should really get that out. And I've had people ask me, well, how do you get it out of the hole, Mike? Honestly, the easiest way is a drill bit. Get yourself a cheap little hand vise like this, okay? That's all that is, just a little hand vise. Actually, this even has storage in the end of it for drill bits. And pick yourself up a cheap little set of numbered drill bits, and just pick a drill bit that's a little bit bigger than the hole. And that's pretty much what this drill bit that's in here, it pretty much just lives in here. I never change it. And I actually have a couple of these, but this is the one that I use the most. And this drill bit is the proper size for just slightly enlarging the holes for most components on a radio like this. And that's the easiest way to get the glue out, because that glue is actually soaked into a little bit of the surface layer of that hole. So you just take the drill bit, hand vise, I just stick it down in there, twist, 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 bam. Pull it back up through. All the glue's been removed out of the hole. You can either turn the radio over and tap it on the bench to get the dust out, or I just use a vacuum cleaner, and problem solved. No more glue. And while I was in, like I say, I replaced the transistor and capacitor, because if you can see the lead on this thing, look at this right-hand lead, how corroded that is. Okay, there's no way I'm going to get that stuff cleaned off properly. Again, it's just easier, and in the long run, just cheaper, because it's not taking up time. Just replace the part. Same thing with the tantalum capacitor. You can see the glue's all bridged across it, and you got to remember, this stuff also becomes conductive when it starts to turn dark brown like that. So yeah, just easier, just put a new tantalum capacitor in there. So that's done. Fingers crossed. Let's hook it up and see what it looks like. I get a feeling that should have fixed it, because like I say, the synthesizer circuit, where's my scope probe? It's back there. The synthesizer circuit, taking signal measurements, looked fine. It was the output from the VCO that looked all screwed up. So let's turn her on. Ha ha ha, look at that. Now there's going to be a little bit of jitter there. That's actually normal, but it shouldn't look like a fluctuating, like a slinky spring going down a set of steps. That looks like what I'd expect. Every once in a while you'll see a little bit of jitter there. That's normal. I can, pull another radio off the shelf and mint, NOS condition, and you'll see that same thing. You'll see a little bit of fluctuation there, but it's not doing this, which was obviously, just horribly wrong. So I guess the next thing is we need to do a transmit test. So let's get the spectrum analyzer turned on. Get my directional coupler hooked up here, which goes to a dummy load, and then the sample port on the directional coupler goes to my splitter, and then actually goes to the scope and the spectrum analyzer. And I'll get a microphone plugged in here. Okay, let's see, 27.205 megahertz. We'll do the span to 30 kilohertz like I had it previously. And grab the mic, fingers crossed. Ha ha! Look at that! It fixed it. Like I said, it looked like a VCO problem. What's the main component in the VCO circuit? The VCO block. So we can even take it down to the span down to like 2 kilohertz now, and see how stable it is. Transmit again. Yeah, that looks good. Yeah. The carrier's not wobbling back and forth, and you can see it has fairly well defined. It drops down. Like I say, especially if we go back out to 30 kilohertz, like I was showing before, and it's what I had said. Actually, I think we were using the communications test set to look at it before, but it's still, you're looking at the same thing. You should have a nice sharp peak like this pointer here, and that's it. It should drop off really fast, and you'll have the noise down here, but it's going to be, 50 plus dB down from the fundamental carrier, and that's what we want to see. So no doubt in my mind, that's pretty much probably the last thing I need to do to this, other than reinstall wire ties, get the boards remounted. Well, actually, I need to leave the boards loose until I do the alignment on this thing. But yeah, that has definitely fixed her up. So let me just dump out my container here, and I'll show the rest of the parts that were replaced, since I am pretty much now done, except with the exception of a few more electrolytic capacitors. I really need to go through, and I just have to check every single one to get rid of all of these. Now, 3 of these are actually name brand, but those were the ones that were installed for that audio modification that went bye-bye. These, I think these were Nichicons, were they? Yeah, these were Nichicons. But yeah, these are bipolar capacitors. But like I say, that's not what's supposed to be in the radio. That was part of a modification. These other tantalum capacitors you see in here, again, they were not supposed to be, especially at these values in this radio. That was another part of an audio modification. It had, and there's a ceramic that was replaced. That one was actually that was replaced because it's got glue on it, I think. Yeah. There's one of the 2 SC2999s that was replaced. Couple more, like I say, cheap parts. It's easier, when the lead like this one, the lead's all corroded. because it had corrosive glue all over it. Just replace the blasted thing. Oh yeah, here was another one. Guess this was part of the modulation modification. There's looked like a diode, and actually, if I can get it pulled out of here. There. Yeah, resistor and a diode bodged in. That was backed by the modulation transformer. So yeah, bye-bye modification. We don't want distortion. And also there were two, not one, but two solder bridges across some of the pins on the balance modulator here. Those were undone, so sideband should be nice and clean now. So let me swap out the last couple of these no-name caps. Like I say, there was just some oddball brands. Like I say, some of these needed to be changed because they were the wrong value. They were part of some of that audio tomfoolery that was going on in there. But other ones, yeah, they're just, I'm not going to let this thing go. I know this customer, he wants a good quality radio, and Chong, whatever the heck you want to call it, Chengxing, I don't know. we ain't gonna leave that in there. So let me do that. We'll come back and we can take a look at transmit, and also take a look and see how transmit modulation looks on the oscilloscope as well, and the spectrum analyzer once I get done. Like I say, should be a good working radio now. We've got all of the high-powered, which just ends up, high power and swing mods. And actually, speaking of swing, you remember I had said how the RF power meter trimmer potentiometer in here was cranked full, whatever direction it was, full clockwise or counterclockwise rotation. That's why. It's because this radio had so much swing. Well, all that swing ain't on the channel you're on. This radio is on channel 20 right now, all doing all these modifications, all these parts that I removed. All that does is, all that new swing power you got, yeah, well, it ain't on channel. The large majority of that power is in adjacent channels and out in harmonics, like at 54 megahertz or higher. It's distortion. It just sounds horrible. If it looks bad on a scope, looks bad on a spectrum analyzer, and sounds bad on air, and it's making more power, and you're not seeing it on the channel you're on, that's also hard on the radio. Those two little guys back there, the driver and final, and actually, your AM regulation circuit over here, you're going to be running these components balls to the wall. Radios like this, the way it was originally, are really good for one thing: having drivers, finals, and regulators burn out in them because they're running the red line all the time. If you set the radio up basically the way the manufacturer designed it, with just some minor little tweaking, you don't need a massive pile of parts to go doing modifications. Just a good quality alignment. You'll have a radio you can be proud to use, and it will last you for decades. There's no reason, honestly, that a driver or final transistor should ever go bad, probably in most people's lifetime. I see radios all the time that are 30 plus years old. People use them all the time. They're the original owners, and they still have the original drivers and finals in them. That's because they don't have their radios cranked up to the max. It's really simple, people. If you want more power out of this, buy an amplifier. Don't try to do it in the radio. If you do, you're just going to end up burning up parts in your radio eventually. So, let me do the last little bit of work I need to do to this, and we can see what it looks like after I'm done. Okay, so I think short of putting the covers back on it, she's pretty much done now. So, this radio has been a chore or a challenge. So, yeah, lots of modifications that just plain should not have been done have all been removed now. Just basically the channel board, it's got an echo board, the fancy lights and all of that. But yeah, other than that, yeah, it's pretty much back to stock now, the way one of these radios should be. Like I say, they're good performers. I have it hooked up to an antenna right now. I don't know if there's even anything. Yeah, there's some really, really weak signals. There's not a lot of skip coming in right at the moment. But It's definitely receiving a lot better now. And like I say, I think that was actually a twofold problem. The receive mod, like I said, I don't like using those two SC2999s. It's just too much gain, especially just when you install more than one. One, okay, yeah, you probably, as I say with the diodes, it's kind of the juice ain't worth the squeezing. But when you start installing more than one, yeah, that's just way too much gain for the receivers, and it just, because you're amplifying all of the noise in with the signal that you want, so you can get the same thing just by turning the volume up. The other problem was, which I think may have been causing a lot more of the problem, was the VCO block being off, because in sideband, that frequency jitter you saw, now that was happening at a really fast rate. It's not like frequency drift, where over a period of 5, 10, 15 minutes, half hour, or an hour, a radio may change frequency slightly as it warms up or cools down, because crystals and other components in the VCO and the synthesizer circuit are changing tolerance slightly and will affect your frequency. Yeah, that frequency jitter you saw on the oscilloscope from TP1 at the output of the VCO, that's a very high frequency. So that would have manifested itself more as audio distortion, because it was happening so fast. So yeah, fixed those two things, and I think, like I say, that pretty much wiped out the receive. The transmit, yeah, it just had all kinds of problems. Again, the biggest one being the VCO. We had the pyramid-shaped, carrier on AM, and then sideband would have been the same thing. It may have been aligned on frequency, but it would have been jittering over, good Lord, probably 9+ channels. It would have been swinging frequency back and forth. It primarily would have been on channel, but all that other trash off frequency, yeah, it just would have completely destroyed transmit audio. And then on top of that, all the audio modifications. Limiter circuits removed, bypass modified, wow. So with all of that done, good working radio now. And actually, if we hook it up to, we'll get the antenna unhooked and hook it up to the directional coupler here. And we need a microphone. Let's see. Make gains up the whole way. Stick it in AM. And what do I have that set to? Channel 20. So let me put the radio on channel 20. And, whoa, turn the talkback off. So there's the carrier. Now I have the spectrum analyzer set to a span of 10 kilohertz or one channel, and you can see we have a nice peak there. And as I said before, we should have all the other trash should be way down here. And if we go again back out to span of 30 kilohertz or 3 channels, we can see again it's not tapering off at a fairly gradual angle out towards the edges of the screen. It drops way down, and then the rest of it's just down here in the noise floor, which is what we want. And we'll go back to 1 channel's width, or 10 kilohertz. And if we, let's see here. Oh shoot, I got the speaker. I got hooked up to it right now. It's going to have talkback whether I turn the talkback feature on or off. That's the way I have that one grounded, actually just for talkback. Okay, so we'll key the microphone, and I'll just give it a whistle and take a look at the oscilloscope. Nice sinusoidal waveform, just like we're supposed to be, set at 100% modulation. Looks good on the spectrum analyzer. And switch over to sideband, and we see just what we'd expect to see on sideband. Again, if I give it a whistle. So if you look way over here to the right, that watt meter, because all 3 of these instruments are attached into that, well actually that's in line with the coax cable before the directional, well actually after the directional coupler. coax cable comes out of the radio, goes through the directional coupler, comes out of the directional coupler, through the inline watt meter, and then down to the dummy load, and then the directional coupler's sample port goes to a 2-port splitter combiner, which then feeds both of these instruments. But the wattage on sideband, see, right about 14 watts, so it's actually a little bit high, which is fine. It's actually very clear. On double tone test, still very clear signal. So I was able to squeeze a clean 14 watts out of this on sideband with no distortion. So there you go. Basically just, like I say, it's a shame when you see radios like this. You get a little bit of extra light up here. It's really a shame when you see radios like this that were probably in really good, well, with the exception of the VCO circuit. I'm sure that was probably screwed up before this radio got worked on. It just didn't get fixed, and it was screwed up when it left. But other than the VCO circuit being screwed up, the radio was probably fine before. It had all these unnecessary modifications done to it. It just destroyed the radio, and then they all have to be removed. I mean, what a great waste of money. So, you get a radio like this, recap it in an alignment. Well, and remove the glue. But other than that, they really don't need a lot. Other stuff that had been done to this, I can see, new heat transfer compound applied to the semiconductors. But that's really it, people. Just normal maintenance. What I call the 100,000-mile tune-up. You don't need to go doing a bunch of crazy modifications, because it ain't really going to do nothing for you but make you sound worse on air. So there you go, a radio that had just been basically rebuilt again, but rebuilt properly now. The only thing I do have to still do to this, and I have to remember before I put the covers back on this radio, I have to reflash the Channel King board, because this does have a weird, it's got a bug. It was just a programming bug. Didn't get noticed for some time. Actually, a good many of these boards went out with that bug. If you look at the channel, or the frequency plan for CB radio, when 23 channel, or when radios went to 40 channel, the frequencies really jump around. You go from channel 23, which is at 27,255, but then channel 24 is 235, then you have channel 25's at 27,245, and then you pick back up with channel 26, which is then 27.265. That's because 27.235 and 45 were missing channels used for other things before 40 channels came around. When 40 channels did eventually get authorized for the CB channel, those frequencies were no longer being used, so the FCC reallocated them to the CB band, and it just kind of threw the... Honestly, I wish when they had gone to 40 channels, they would have just redone the entire channel plan for CBs and just made it straight through with no skips. But it is what it is. So, but yeah, I need to reflash the current firmware into that, so the channels are actually correct when you go from 23 to 24, 25, and 26. Because right now there's two channels there's actually two 27.255s right now because of that bug. But like I say, easy to fix that with a firmware reflash. So there you go, a Cobra 148 GTL custom that has been massively decustomized.